So we'll start out, make sure every page should always have your total first and last name nice and neat with a nice dark pencil. And today someone said that it's a 26. So we're almost at the end of this month. And we're going to look at a lot of things that have to do with complex numbers. Complex numbers. And you're 1B. All right. The symbol for complex numbers is this kind of like italicized C. It stands for, yes. You don't see it. Nobody. I'm talking the whole time on all those things, and you didn't. I can't find the one you're talking about. Well, I don't even see it up there anyway. I think my thing went off the. Yeah, it's not even connected anymore. It was on there when we were looking at the email, that's for sure. There it is. All right. Sorry about that. The eyes in the back of my head, I had them closed, so I couldn't see. And that's probably too much light in the room. So let me dim it down a bit. Let me reach. Well, that is on. Off. One's on in, one's off. Why does it seem so much brighter? We change it. How's that? Is that better? So you can see up here. All right, I'm sorry. Thanks for saying something. C stands for complex numbers. R stands for real numbers. Z stands for integers. N stands for natural. There's probably a couple more we'll probably see. But anyway, you've already dealt with imaginary numbers. So what if we put an imaginary number with a real number? For instance, here's an example. 5 plus 2i. You don't have to be a genius to tell me which part was imaginary. Go ahead. Let me hear you. Which part is imaginary? Beautiful job. What part is a real number? 5. Could that be a decimal? Could it be a 1.2? Could it be negative? It can. And you found out you could have negative imaginary numbers too. I'm sure that we added some imaginary numbers in the other assignment. So you could have a negative imaginary. But you put both those together, a real number of 2 and the pure imaginary number, the real number 2, when you connect it to I, becomes an imaginary number. So we just say that the standard form for imaginary number is an A plus or minus BI. Whereas A is pure real and B is it's a real number part. I don't know how else to call it. It's a real number part in front of I. So we call that whole thing there a pure imaginary. That part is. But once you put it together with the real number A, it's no longer a pure imaginary. It's no longer pure. It's watered down with the real number called, in this case, a 5. That's way more information than probably you need to know. Point is, how do I apply some operations? We're going to do some adding and subtracting. And I bet you, I could probably bet money that somebody would know how to add those two together. Or at least, what would be your guess? If you had to guess, you would add the negative 11 and the 9? So you would put those together. What else would you do? You would take the plus 3i and add it to the 2i. Told you somebody would know. It makes sense. To put them together, The real part can only go with the real part. The pure imaginary part can only go with the pure imaginary part. So this really isn't that bad. I guess it reminds me of combining like terms. Remember we've done that before when it's negatives and positives and x's and x squares, and we could combine them. It's almost the same idea. So this makes me go, yay, I already know how to do this. It just looks a little different. So if I follow through, I think you would agree that my final answer would be a -2. And let's see, both of those are positives, so that's going to be a plus 5i. Did anybody else agree with that? A -2 plus 5i's. Okay. So let's do another one here. Okay. It's the same thing. Would you agree that the 4 and the 7 must be combined? That's 11. And then help me out with this plus I minus 5i. What would happen with those? How many i's do I have with a plus I?
1.
Yeah, there's a plus 1i. And that's a minus 5i. Aren't you really thinking of a 1 minus 5? And then there's an I next to it. So what is 1 minus 5? 6? It's a 6?
-4.
-4? Which one is it? Let's vote. Who says 6? Oh, got another vote over there. We got at least 2 votes with -4i. I would agree with that. -4i. Okay, let's see. It's getting harder. What do you think happens if we're subtracting complex numbers? What do you think the most important thing there is to do? Think about in the past. When you had a negative in front of a parenthesis, what has to be done? Somebody should know, right? Sign in, please. You grab your packet on the table there, on the desk behind you. What is this? What do I do when I'm saying this? What am I asking you to do? To make sure you have to make sure you distribute. So what it really turns into is a 7 minus 2i. Then I have a -2 minus 6i. When I distributed your packet right there, ma'am. So 7 minus 2i, -2 minus 6i. I didn't use any parentheses, so I hope I didn't confuse you. This 7 still has to pair up with this -2. And this -2i still has to pair up with the -6i. So 7 minus 2? 5. -2 minus 6? -4. Are you sure? -8. Why 8?
Because they're both negative.
They're both negative. We add them. Keep it negative. It would be -8i. I know I said today I'm not going to do all the examples, but they only gave me 4 for adding and subtracting, so I kind of have to do them all. Look at number 4. I have the same situation happening. This time I have 3 different complex numbers. But the first one isn't really complex. It's just imaginary, pure imaginary. There's no number added to the 6i. So it's kind of like 0 plus 6i. That's what that one is. But anyway, I have a negative in front of this one, so I got to be careful that I do those. So I'll bring down my 6i, 0 plus 6i, minus the 14. Minus times a minus is a plus I, plus a 5, minus a 3i. I didn't do anything with this term. I did nothing but bring it down. So I don't need to think about a 0 plus, so I'll take that off. But, I mean, technically it was there. So now you have to think about combining all the terms that do not have an I first. There's a couple. We have a negative 14. We have a positive 5. That's it. What is a negative 14 plus 5?
It's gonna be -9.
It is negative 9. Very good. Then I have a 6i plus an I. What is 6 i's plus an I?
7 I.
7 i's, but then I got to take away 3 i's.
4.
Oh, it's going to be a 4i. Yeah, plus a 4i. So here's a new lesson for you, but I hope deep down inside you say to yourself, I know a lot about terms. I know a lot about common terms, and it makes sense. It does make sense from something you knew before. Now we're going to simplify. What are we doing? We are multiplying. Now, I don't really, I think I know what he wants us to do. Recall something in the last lesson. Do you remember what happened if we had an I times an I, which is an I squared? Do you remember what that really is? You made a chart. You made a whole chart where we did an I to the first, I to the second, I to the third, I to the fourth. You kept on going. We even went I to the 7. It is a -1. Very good. Remember that, guys. That's why I think she wrote this box. Remember that I times I is a -1. So whenever you can pair them up, every 2 i's that are multiplied together cancel out to a -1. Now, I don't think I need it for number 5. Or do I? Oh, yes, I do. I wasn't looking at it. I thought I just saw a 2, but that's a 2i times an 8. Then it's a 2i times a -3i. Yes.
Can I go to the right side?
Yes. Yes. So when I do 2i times 8, you just have to handle the 2 and the 8. Keep the I. So what is 2i times an 8?
16.
16 what? 16, not I squared, just 16i. They both don't have an I. But when I distribute it to the -3, I have a 2 times a -3. That's a -6. But now I have an I times I squared. And that turns into a what? No. Just this piece turns into a -1, right? So I'm going to write 16i.
Sir,
Yes.
what is that number?
Where at?
The one right there next to the parentheses?
This one?
Yes.
6. It was a -6, to be honest with you. -6 times, this becomes a -1. You're multiplying the -6 times the -1. You're multiplying that. It doesn't affect the 16i. It's still there, 16i. But what happens to a negative times a negative?
Becomes a positive.
Positive how much?
But 6.
Positive 6. Now I'm going to ask you a question. Do you like that answer?
Yeah.
Did it make sense? What if I told you that old white people from hundreds of years ago said, you're not supposed to leave it like that. You're supposed to put the number without the I first. Yeah, then the 16i. Well, I'll be honest with you. If I'm grading you a bunch of papers and I saw you write this, I'm not taking off any points. I might write to you A plus BI to remind you that the standard form, and it was written up there somewhere, where was it at? Right here. The standard form means the way we're supposed to leave it. Okay? I know some of us are rebels, So we want to do the rebel form. I get it. All right, let's do number 6. Now I'm distributing a negative I 1 time, 2 times. So to make sure that none of you get lost, I'm probably just going to write them both out, okay? I'm going to write a negative I times the negative 2 plus the negative I times the 10I. Will I always expand it like that, or will I do some of it in my head? Depends how I feel. You know, it depends if I think I can do it without seeing it like this. It's up to you. Do as much work as you need to so you don't make mistakes. Now, help me out. Negative I times the negative 2. Are there any secrets there? Positive 2I, exactly. Plus a negative I times the 10I. Is it a 10? Negative 10 what? I squared. But do you remember what I squared really means? Oh, okay. So there are those people a lot smarter than me would have applied that already, but I'm going to take it slow. 2I. That's going to give me a negative 10. I don't care about this plus sign anymore, you see. I have a negative 10 times a negative 1. It's important to see that this becomes this. So I'm still not done yet though, so let me go back and say equals to 2I. What is a negative 10 times a negative 1? Positive 10. There's your, is that a final answer? Or, oh, you want to flip it? Because you want to be proper. Put the real number 10 first, plus the 2I would be the best answer. But again, not all of us catch that. Sometimes we're just so excited we got it done that we just move on. I get it. I've been there. All right. Check this out. Remember we had binomial times a binomial? That's the same thing as a binomial times a binomial. Do you remember how we solved them? When we multiplied them, how did I do it? There's a magic word. Do you remember a magic word? When I was doing something like this, x plus 7 times x minus 4. Do you remember how I multiply those? First times first. Outers. Inners. And last. What was that word? F-O-I-L. Foil. You do the same thing over here. 7 times 4. You want me to write them all out, or can we do it? Who needs it written out? Every little number first. Don't be afraid. If one person says yes, write everything down first. All right. 7 times 4. That's the first. Then I do the outer. That's the O. That would be plus a 7 times a negative I. Then it's the inner, which is plus a, when I say I times 4, please allow me to put 4 times I. Plus last times last. I times I. I times I. You okay over there?
Yes, sir.
Are you ahead of me? Oh, that explains it.
I can't really see.
You what?
I can't see.
You can't see?
Too much on this side.
What do you mean? I can read it back to you.
Yeah, can you say?
7 times 4 plus 7 times a negative I plus a 4 times I plus an I think I messed up.
Was I?
It was an I times a negative I. And I'm glad you made me do this because I don't have a negative there. I times a negative I. I'm so glad you made me look at it again because nobody else caught it either. Maybe somebody did. They didn't want to hurt my feelings.
Wait, what was after 4I?
A plus I times a negative I. That came right here. This I times this negative I. So I probably won't write all those steps. Like I would have done 7 times 4, I know was 28. Then 7 times a negative I would have wrote minus 7I. And then an I times the 4, I would have write plus 4I. And then an I times a negative I is a negative I squared. Why is that important, that I squared? What's that I squared become? It does. So pay attention here. 28, these two both have i's, so I can add them together. Negative 7 plus 4 is how many? Close to a 3. What kind of 3? Negative 3. That's right. Negative 3i. Minus, there's a minus here, times, you said that this, let me use a different color. This is a negative 1. True? So do you notice that I have a minus of a negative 1? What happens with a minus minus 1? Okay, so that turns into a 28 minus 2i plus 1. Well, would that plus 1 go with the 28? So your final answer should be a 29 minus the 3i. I would say this is probably the most important problem that we got done today. Probably the most important problem because it uses stuff you already knew. However, there's that pesky imaginary number affecting how it performs. So unless I'm wrong, I would do that again at home. Make sure you know how to get the same answer. And if you get a different answer, let me know where I messed up.
What's the answer?
I think it's 29 minus 3i.
Okay.
I think. Unless somebody in here can help me out if I made a mistake. I got people asleep, so they're not going to help, are they? Or it looks like she's asleep. Maybe she's not really asleep. I saw a hand moving. All right, so here's another candidate of FOIL. So this time I'm not going to do all the steps. Help me out here. First, 2 times a negative 5. How much is that? That's your first two terms. What is that? Negative 10. Very good. Now I got to do the outsides. 2 times the negative 3i. 2, this is my outsides. 2 times the negative 3i. What's your gut feeling?
6I?
A 6?
Negative 6I.
Negative 6i. Very good. How about a negative 4i times a negative 5? That's my inner. Ooh, you're so good. Positive 20 what? I. Nice job. And there's only one set left, the last two, which is the 4i, negative 4i, times a negative 3i. Positive what? 12i squared. Positive 12i squared. I wrote that. When I grow up, I won't write the I squared. I'll automatically know that my plus 12 turns into a what? When I grow up, I will know that my I squared makes this plus 12, turns to a negative 12. But for right now, I'm just going to keep it in here. So negative 10 comes down. Negative 6i plus 20i is how many i's?
That's gonna be,
Are we in the right seating chart by chance? You three? Or two? No, you two.
Oh, yes, sir.
Wow. It's amazing. Usually if I put you in a sitting chart, you're not that friendly with your neighbors. You say, I don't want to sit by them. But negative 6 plus 20 is how much?
negative 14,
And is there still an I?
yes.
Yes. And then that plus 12 gets multiplied by a negative 1, right? So if you want to do it before, do it now. It doesn't matter to me as long as you recognize that turns into a negative 1. So that gives me a negative 10 minus 14i minus 12. That's what happens here. That's what happened here too, in case you saw it. The negative 10 now goes with the negative 12. So you're going to have to put this together with this. What is a negative 10 plus a negative 12?
22, negative 22.
Very good. Most people say it's 2. Most people yell out fast, 2. Or they'll say negative 2. But because they're both negative, Julian knows that we add them together and keep it negative. Well, negative 122. Where'd that come from? Negative 22 minus 14i should be the answer. All right. I'm not going to do the last two. I'm going to save those probably for a bell ringer or a quiz problem, but I will set up number 9. I don't want you making a mistake. That's squared. You should rewrite it as 6 minus 2i times a 6 minus 2i. It's the same thing written twice. Okay? So I got you started. Whew, that's a lot of thinking. Let's go to the next page. What are they doing? Complex conjugates. What does she want me to do with that? Two complex numbers in the form of a plus bi and a minus bi. They're like brothers and sisters. They're together, called a conjugate pair. That's what they are. So they're telling me that if you have it, when you multiply them together, something unusual happens. If you look at number 11, we're going to do all the work, okay? But it's a conjugate because they're the same thing except for one's a plus, one's a minus. Once you recognize it, you ought to be able to do number 12 without doing hardly any work at all. Conjugate pairs are beautiful. When you multiply them together, the i's go away. The answer is just a real number. So when you look at this, did he say that? The product of two conjugates is always a real number. No more i's. So, but let's see how it works. Let's use FOIL. What is 8 times 8? 64. What is 8 times a negative I?
85.
What about the negative?
Negative 8i.
Negative 8i. What is an I times 8? And they're both positive.
It's 8i.
Plus 8i. What is I times I? A negative I.
Negative I
Negative I squared.
squared.
And what is what's an I squared actually?
Negative 1.
Okay, so that's what happens here. 64 comes down. Add these two together. What's a negative 8i plus 8i? I know you're afraid to say it.
Plus 8i. That's 16i.
Well,
It's 1.
Oh, it's 0.
that's a 0. They're both the same thing. One is negative, one is positive. That turns into 0. But I still have a minus I squared. So isn't that a minus of a negative 1?
Yeah.
So isn't that really a plus 1?
Yeah.
That's really a 64 plus 1, which is how much?
65.
You see how all the i's disappeared? Can you think about how that worked? All I really cared about is 8 times 8. Again, with how much?
64.
And an I times a negative I, which is how much? Is it a negative 1 or a positive 1? Well, the I times I is a negative 1, but there's a minus in front. Always becomes a plus 1. I times a negative I is always a plus 1. So it's the answer is a 64 plus 1. Now, you don't feel confident to do that guessing? You don't have to. I wouldn't expect you to do it till you've done like 100 of them. But if I'm looking at this, what would be your gut feeling? And then we're going to check it to see if we're right. What two numbers you think are important? Would you think the 5 times 5 is?
I think 5 times 4 is
Well, what's 5 times 5?
25.
So I need that, right? Now, you already know that the outside and inside will cancel. That's a plus 20, that's a negative 20, they're going to cancel. So just worry about the negative 4i times the positive 4i. That's all I care about. How much do you think that's going to be?
16i.
Well, what's I times I?
Squared.
I squared. It turns into a negative 1, right? So it really turns into a negative 16 times a negative 1, which is really what? 25 what?
6.
Say it again?
Positive 16.
Plus 16. You can look at that and say, oh, 4 times 4 is 16. So it's going to be a 25 plus 16. It always will work out. But if you have to work it all out in detail, by the way, that answer is going to be, if you do my math right, 35, 40, 41, I think. 41. But if you have to do the 5 times 5, fine. And then plus 5 times 4i, then negative 4 times 5i, then a negative 4i times negative 4i. If you have to do that with FOIL, you're allowed to do it, but I'm hoping you can see it's a 5 times 5 plus a 4 times 4. It happens all the time, okay? But anyway, that should come out the same. 25 plus 20i minus 20i. Minus gives me a plus. And an I times I, well, actually it was a minus. Look at it again. One's a minus and one's a plus. So I should have said a minus, that's a plus. That gives me a plus, a negative 16 times a negative 1, which is a plus 16. So it comes out because those cancel. I have a 25. That becomes a plus 16. So it's the same thing I have right here. It's okay if you don't see it.
So what's your answer?
41. And I don't know why they only gave us 2 problems that did the conjugate. Because you actually are going to use the conjugate in a couple minutes. A lot. Okay? Because now we're going to do dividing. Okay? Most of the dividing is simple like you always have done. Like this is going to be very simple. But let's see what rules they have. Watch out. I cannot be in the denominator of a complex number. I wonder who said that. Some old white man, 400 years ago, said you're not allowed to leave the I down there. Well, the only way to remove that I down there is to multiply both top and bottom by an I. Because I divided by I is really a 1. You agree with me? I divided by I is 1. So what I'm doing is I'm multiplying this fraction by a 1. But look what happens. Why does this help? 10 times I is 10I. What's 2 times I times I? 2I squared. And what it really is I squared? Oh, that turns into 10I divided by 2 times a negative 1. What is 2 times a negative 1? Two times a negative 1?
-2.
So that turns into 10I divided by a negative 2. You want to take a guess at the final answer?
-5.
Negative 5 what?
I.
Negative 5I. So did we get rid of the I in the bottom? Yes, we did. This does not have an I in the denominator. So that old white man from 400 years ago, he's not rolling in his grave. Because when he saw that problem, he goes, oh, I can't handle that. It's against the rules. And most of us, as we learned this, we said, what's wrong with an I in the bottom? It looks okay. I guess some sort of person who's doing it in an application problem didn't like it. So when I look at number 14, what do you think the most important thing I have to do first? Different though. I over I. That, I was wondering, where did the I cubed come from? Equals to a 4I over negative 9 times I squared. And what's another name for I squared?
-1.
So 4I over negative 9 times negative 1. What's a negative 9 times negative 1?
A 10.
No, we're multiplying.
Shit. It's a positive 9.
Positive 9, so it's 4I over 9. That's the answer. Not 4/9. I had an extra I in there for some reason. I'm glad I caught it, but I wish somebody else would have said, why did you put I squared there? I didn't notice until I was looking up there at the top. All right, now, let's see. Let's see. What do you think would get rid of the I in the bottom? First of all, I hope you look ahead for a minute. If you wrote this as two fractions, it would look like this. 28 divided by 4I minus 8I divided by 4I. You do know that if you have two things in the numerator, one thing in the denominator, you can write that as two fractions. That may help you. I mean, it helps me with one thing for sure. I see that I could take, how many 4s go into 28 if I wanted to say it? 4 goes into 4, 1. 4 goes into 28, how many times? That's 24.
7.
7. How many 4s go into 4? 1. How many 4s go into 8?
2.
2. So let me rewrite what I have. Equals to 7 over an I minus a 2I over an I. Are you worried about the I over here? Isn't I over I just a 1, so it goes away because that cancels that I? It does.
But doesn't it cancel the I from the beginning?
I still have it there. 7 over I minus 2 now is what I have. So you didn't get rid of that I. Let me clean that up. 7 over I. You still have an issue over there. So you're going to have to take this side multiplied by I over I. That gives you 7I over I squared minus 2. But what is another name for I squared?
-1.
That gives me 7I over a negative 1 minus 2. And what's 7 divided by a negative 1?
-7.
So negative 7I minus 2. Do you like that answer? You think the old people from 300 years ago, 600 years ago would be okay with that answer? Or would they be saying, no, standard form? They're probably going to yell at us and say minus 2 minus 7I should be the answer you want to put that in. I don't know what the big deal is, to be honest with you, but I'm a good employee. I follow the rules, even if I don't always see the importance of it. So I need to drop down to one of the bottom ones here. I can come back up if there's time and look at 16, but I got to look at this one here. Because this is completely different. You know how I broke that up into 2 fractions? Number 15? I was able to do that because the numerator had 2 pieces. You might want to finish this problem first, though. This had 2 pieces at the top and 1 at the bottom. You can change that to 2 fractions. But number 17, you can't. You can never divide a denominator into pieces. So you're stuck with it. And the only way you can get rid of the I in the bottom, wait for it, is multiply top and bottom by, I wonder if you remember what the word is. I'm going to write it and tell me what the word is. 5 plus I over 5 plus I. Which, by the way, 5 plus I over 5 plus I are the same thing, so it's really a 1. But what is 5 plus 1, or 5 plus I compared to 5 minus I? Is there a word for that? Is it on this page? It's up there. Yeah, can you pronounce it? Conjugate. Very good. Very good. You multiply top and bottom by the conjugate of the bottom. You might want to write that out. Multiply top and bottom by the conjugate of the bottom. I know what you're thinking. Couldn't I have done that up here, multiplied by the conjugate of the top? I don't think it would have gotten rid of the I in the bottom. I would have to try it. I don't think it will. I think I kind of did number 15 the long way out because that's the only way to do it. But if you do it on your own time and prove me wrong, I'll give you a lot of bonus points. But I do know that if it's in the bottom, if I is in the bottom as a complex number, you have to multiply by the conjugate of the bottom. And it's a lot of work, guys. It's a lot of work. It's almost too much that we get, I don't want to do it. But you got to take this -2 and you have to distribute it here 2 times. So that gives me a -2 times a 5. That's a -10. And a -2 times an I, a plus I, is a -2I. So there's your top. Now your bottom. Do you remember this shortcut? I don't have to do FOIL. All I have to do is 5 times 5, which is 25, plus how much? What always happened with these two? That negative goes away, it just becomes a plus. What's an I times I?
Squared.
I squared, which is a,
Negative.
and there's a -1, so it becomes a plus 1. No I's, just plus 1. So that turns into 10 minus 2I divided by a 26. Now, I want to give you caution here. I like the answer, but if this was on Canvas, the answer is going to be reduced. And you're going to say, my answer is not there. I did all this work, and I don't know why I don't find the answer. It's because the 10 and the 26 and the 2 all share a number. What number would they all share?
2.
So divide all three of those by a 2. Divide this by a 2, that's a 5. Divide this by a 2, that's a 1. Divide this by a 2, that's a 13. So your best answer is 5 minus an I, because it's a 1I, all divided by how much? A 13. Was that so ugly? You see, you're going to look at all those answers and say, where's my answer? Because they reduced the thing. So that's another very good problem to redo, okay? And I know I have to do another one only because these are hard. I'm just checking to see what's on the next page. Only homework would be to probably study these problems. Finish anything I haven't done. So since there is an I in the bottom as a conjugate number, 6 plus 2I, I'm telling you the only way to make it go away is to multiply top and bottom by the what? Conjugate of the, what is the conjugate of the bottom? It's going to be the same thing, but the opposite sign. 6 minus 2I over 6 minus 2I. Why am I using minuses? Because the bottom had a plus. So the top one, I'm going to have to distribute that. That gives me 5 times 6 is 30. That's 30 I's. 5I times a negative 2I. I'm going to write it out. So here's what it is. It's a negative 10I squared. I'll simplify that in a minute. Over the bottom. You want to do FOIL? Go ahead. But I'm going to do it the easy way. I'm going to go 6 times 6, 36, plus a what? What do you think it's going to be? 2 times 2. 2 times 2. 4. And if you do the plus 2I times a negative 2I, you're going to see that's a negative plus 2I. Where did I get that part? Oh, it's supposed to be a plus 2I. Plus 2I times a negative 2I is a minus 4I squared. But a minus 4I squared is a minus 4 times a negative 1. You see that? Which is a positive 4, which is what I put here. So I'm skipping all that thought. Just saying 6 times 6 plus 2 times 2. That only works when they're conjugate pairs. So this answer turns into, be careful, this is a 30I minus negative 10. That is a negative 1 times 10 is a negative 10 minus 10 over 40. What is a minus 10 going to be? Positive. So that's 36. Was it no, it's 30. 30 plus 10. Wait, no, it's not. It's a 30I plus 10 over 40. You want to take a guess at how that reduces?
10.
Say it again.
10.
Divided by 10. Can you do that? 30 divided by 10? 3. 10 divided by 10? Uh-oh. 1. 40 divided by 10? 4. Very good. Very good. I'm not saying they always reduce, but a lot of times they might, okay?
What was it, 40?
I think it's 3I plus 1 over 4. Because it was a 30 and a 10 and a 40. They all divided by a 10. It is, what you doing? I have my thing down. 31. Since there's no homework today, let's just do the next one here. Did you understand how that reduced? If it was open-ended and it wasn't a multiple choice question, I probably would, I don't dislike the other answer. I'm pretty proud of you to have gotten it. Am I correct? You've never done this before in your life? No, nothing in your Algebra 1 class ever did these? Or your geometry classes? How does it feel doing something you've never done before? Because usually we're always afraid of what I've not done before. I'm afraid of the future. But is it really that bad? Maybe for some of you, but that's because some of you just sit and watch, you know. But it's different though, right? Let's do another one. Okay. There's an I in the bottom, 2 plus I. The only way to get rid of that I is to multiply by what? The conjugate of the bottom. What is the conjugate of the bottom?
2 plus I. 2 minus I.
2 minus I. Very good. So 2 minus I over 2 minus I. Now, since there's a parenthesis around it for a reason, I better go over here and put parentheses around the other ones too. All right, I feel better. Now it looks like reality, okay? Now, I apologize for that numerator. It's going to have to use FOIL. It doesn't cancel. There's no secret. You're going to have to do the 7 times 2, which is 14. You're going to have to do the 7 times a negative I, which is a negative 7I. You're going to have to do the 3I times the 2. That's a plus 6I. And then last but not least, a 3I times the negative I. I hope you know what that means. Negative 3I squared. Exactly. Negative 3I squared. Now, I'm going to simplify that in a minute. Let me just do the bottom, because the bottom is the easiest. Wait for it. 4 plus... Not 4 plus a negative 1. 4 plus 1.
Yay.
Yay. At least there's no I's down there, okay? And if you need to see why that is true, you just got to ask me to break it down for you. But I'm hoping that you see it. But if not, let me finish this up. 14. Okay, I don't know. That's still a 14. The negative 7I plus 6I. There's more negatives than positives. That's a negative I. The minus 3I squared really is, be careful, that's a negative 3 times a negative 1. There you go. Over a 5. What is a negative 3 times a negative 1? Okay, that's 14 minus I plus a 3 all over 5. What goes together? How much is that? 17 minus I all over 5. Does it reduce like the other ones did?
No.
Nope. There's your answer.
Yay.
Yay. You want the last one done for the road? May as well. It's no different than number 19. But I do have a binomial on the top. I do have a binomial on the bottom. So I'm going to put parentheses because I know what's coming. Multiply by the conjugate of the bottom. So I'm going to multiply both top and bottom by a 2.
Plus
plus, because there's a minus here, plus 4i over 2 plus 4i. Now, no matter how hard that top is, the bottom is going to be very simple. The bottom is going to be the 2 times 2, 4, added to the 4 times 4, 16. That's why the conjugate is so valuable. It cancels out everything in the bottom. It turns it into a 20. So simple. But the top, I have to work at it, okay? 1 times 2 is 2. 1 times 4i is a plus 4i. 8i times 2 is the same as 2 times 8i. That's plus 16i. And 8i times 4i. How much is 8i times 4i? Nope. 32 I squared. But you do know what I squared is, right? So that plus 32 really becomes a what? A negative 32. Yes. So it becomes a 2 plus, what's 4i plus 16i? 20i. You already said this becomes a minus 32 all over the 20. So 2 minus 32 is what I have to worry about. 2 minus 32. Negative 30 plus 20i all over 20. Does it reduce?
By 10.
By tens?
Yeah.
Are you sure? So divide everything by a 10. What's 30 divided by 10 or negative 30 by 10? Negative 3. What's 20 divided by 10?
2i.
Plus 2i. What goes in the bottom? 2. A 2. Nice job.
So what does it say, negative what? 2?
It's a negative 2. Yes, sorry, it does look bad. Negative 2.
I thought it was 3.
What are you?
Negative 3. That's what I said. You're right. Negative 3. It looked really bad. Negative 3 plus 2i over 2. You're right. You're just trying to pull my chain, right? You won. Wow. Heavy duty. The math that somebody would say, sir, when will I use this in the future? And I'm going to be totally honest with you. I have never had to use it in the real world. Have I had to use it in future classes? Un poco. Just a little bit. It doesn't come up very often, but when it does, thank God I know about the conjugate because it may come up in another advanced math class. But other than that, guys, here's one of the things we learned for fun. Because you all had fun, right? Oh, it's another set of notes. There's no homework today.